Hello, everyone. Good morning or good afternoon, depending on where you're attending this webinar from. Firstly, I would like to thank you all for taking time out from your schedules to attend this webinar. Welcome to this webinar all. Today's webinar topic, DLMS Companion Standards, Objectives, Merits, and Implementation Challenges. To introduce myself, I'm Gautam, and I take care of Europe and South America market for Kalkitech Applied Systems Engineering offerings. Kalkitech has long been an advocate of open standards and standard-based communication to facilitate interoperability in the true sense. We have been active members of the DLMS User Association from start, and now DLMS is de facto the standard metering protocol used extensively across the globe, excepting North America, where ANSI C12 is still prevalent. A few points before we start off. Since we have a large number of participants, this is a listen-only webinar. However, to facilitate clearing of your doubts or queries that arise during the course of the webinar, you can kindly send us your questions by typing in the chat window during the talk itself. We would try to address them here at the end of the talk or come back to you individually in case we run out of time. The presented talk would be for 40 to 45 minutes, followed by a set of questions selected at random. I would now like to introduce you to our panelist for today's webinar, my colleague Mr. Balagopalan, AVP Metering Services Group. Balu, as he is called, has 14 plus years of experience in the communication protocol domain. He's a member of the DLMS User Association Protocol Maintenance Group, as well as the Bureau of Indian Standards ET13 panel, which maintains the Indian standard. As a lead DLMS consultant to TNB Malaysia, Balu has drafted the TNB DLMS Companion Specification. He has extensive experience on various DLMS companion standards, namely the Japanese TEPCO, Spanish Iberdrola, Dutch DSMR, Italian Gas Metering Specification CIG, the Indian standard of course, SEC, UK, and SPODES. Our offerings, namely the library and tools, comply to a few of these standards, and we can comply to the rest based on interest. Without any further ado, I would like to pass controls to Balu, who would take it forward from here. Over to you, Balu.
Thank you, Gautam, and welcome all of you to this webinar. Moving on to the agenda. So in today's webinar, these are the topics that we will be covering. We'll have a quick introduction to the DLMS COSEM protocol. And after that, we'll move on to the companion specification, the need of a companion specification and what benefits that brings. Then the conformance testing, which generally utilities follows when they are using a companion specification. And finally, some of our tools and services that Kalkitech offer in the DLMS companion space. Now coming to a short introduction of DLMS COSEM protocol. DLMS COSEM is today the most popularly used metering communication protocol across the world. There are more than tens of millions of meters with DLMS protocol in the field, and with mostly in Europe and Asia, with Africa also catching up with DLMS. DLMS is an IEC standard. It is standardized under the IEC 62056 standard and the European standard EN 13757-1. In addition to the IEC standard, the DLMS is also compatible with some other smart grid protocols. Like for enterprise integration in the smart grid environment, the SIM protocol, which is the IEC 61968, is supported by DLMS, there is a specification in IEC 62056-6-9, which allows for DLMS to SIM mapping. So this is for DLMS to enterprise integration. The data which is collected from the field using DLMS protocol from the meters can be exchanged to enterprise IT applications via this mapping protocol. And similarly, another protocol used in the smart grid environment in the substation automation and protection domain is the IEC 61850. So there is a technical specification 61850-80-4 which allows for translation from the DLMS COSEM object model to the IEC 61850 data model. Similarly, for the home automation system, there is a mapping specification between IEC 62056 DLMS objects and the EN 50491-11, the European standard for home automation. DLMS UA, which is the User Association, it's a 20-year-old organization based in Geneva in Europe. It is currently having more than 300 members from more than 60 countries across the world, and there are more than 1000 meter models that are already certified. So that by itself shows the popularity of the DLMS protocol and acceptance of the DLMS across the users, that is the utilities. Now, this slide talks about the three-step approach which is followed in DLMS protocol. So the three-step approach basically refer to data modeling is the first one, then the messaging is the second, and the third is transportation. So the protocol is layered into three. So this three-layer model basically allows the independence of each layer. So each of this layer is tightly coupled with a particular application segment. For example, the data model is tightly coupled with the metering domain. So it has the interface classes, the COSEM objects, and the object identification system defined in the data model layer. So that covers all the metering data of all types of meters. That means electricity meters, gas meters, water meters, and heat meters. Now, the another layer after the data modeling layer is the messaging layer, which takes care of the application as well as the presentation functionalities of the 7-layer OSI architecture. And the layer below the messaging layer is the transportation layer, which takes care of exchanging the APDUs or application protocol data units, which are the payloads, between source and destination, between the DLMS meters and the systems or the devices which are trying to communicate with the meters. So the advantage of this three-step approach or the layered design of DLMS is that there is an orthogonality or independence of each layer. For example, the data modeling layer, which is tightly coupled with the metering application domain, might evolve over time depending on the technological advancement happening in the metering domain. For example, 20 years back, when DLMS was first defined, there was no concept of using the communication protocol for prepaid metering, or no concept of having a built-in relay or a switch inside the meter, or the concept of demand response or load management, monitoring the load and automatically shutting off the load based on the monitored value, etc. So these kind of advanced metering functions like prepayment, demand response, or connect disconnect switch or valve, etc. So these are some of the examples of the advancements happened in the metering domain. So these advancements could be adopted into the DLMS into the data modeling layers of DLMS, and that will not affect the other layers, that is the messaging and the transporting layers. Similarly, there will be advancement happening in related to the messaging layer. The security, the data security, for example, it was not such a critical thing to consider 20 years back when DLMS was first started. So there was no provisions for data security or encryption in DLMS messaging layer initially. But later on, based on the advancement happening in the area of data communications, the importance of data security, DLMS also adopted various security measures. They first introduced symmetric key based security into the DLMS application layer, and later on they additionally added the asymmetric key or the public key infrastructure also into the DLMS messaging layer specification. So that can happen independent of the transporting layer and the data modeling layer. Similarly, the transporting layer also got evolved to support new kinds of data communication medium like power line communications, radio frequency mesh based communications, etc. So this was all made possible because of the design that was followed in DLMS, which allows for each layer to independently evolve or adapt without affecting each other. Now, we will try to see what is the interoperability issue, or we will try to put the context of the need for a companion specification. When we say DLMS is such a popular standard, the most popular standard used currently across the globe, and it was designed in such a good way with the three-step approach, then some of you might have a question that if DLMS is such a good design, then what is the need for a companion specification? Why can't we use the standard DLMS itself? So in order to answer that question, we'll give you an example. So this is an example that we have witnessed ourselves in one of the smart metering rollout project. So you can see on the right hand side of this picture, there is a high voltage event, and that is detected. That event is applicable for 2 meters. The first meter is provided by meter manufacturer ABC, and the second meter is provided by a manufacturer XYZ. And suppose that both the meters detects the high voltage event, and the first meter, meter ABC, reports this event to the head-end system using a data notification request. It is a request in the DLMS application layer, and in the request it packs two information, that is the event code 10 and the timestamp of that event. So the event code 10 is not defined by DLMS. It is something defined by the meter manufacturer themselves. Now the same event of high voltage is communicated by the second meter, meter XYZ, to the head-end system using event notification request. That is another service offered by the DLMS protocol. And here you can see the difference. The second meter is using a different event code, 354, not 10. And it also includes the timestamp of the event. And then it additionally provides a snapshot of certain electricity values that was captured at the time of the event, like the voltage, current, frequency, and kWh. So this snapshot is missing in the first meter. Now, if these two same meters are used in the same project and is communicating this same data, that is the high voltage event, to the common head-end system, then it will be a difficult task, a big challenge for the head-end system as well as for the MDMS system, meter data management system. So even though both the meters claim to be DLMS, these kind of situations can happen, and this example is something that we have seen recently in one of the project, smart metering rollout project. So this is an example of interoperability issues. There could be several other issues. And the most difficult part of the interoperability issue is that most of the times this might show up during the final phases of integration. And that will end up wasting a lot of time in discussing between various suppliers and utilities and system integrators and debating and finally reaching to some agreement or a change request, which eventually again lead to more time for somebody making the change either in the meter firmware or in the head-end system to adopt these two different kinds of implementation, and the utility finally ending up paying for the additional change request. So that was just to give a context of the need for a companion specification. Now, what is a companion specification? To ensure the true interoperability, the utilities need to define a companion specification. The original idea of DLMS is not that DLMS can be simply used or fully used as is into the utility projects. The utilities or the users need to apply DLMS according to their requirements. Or in other words, they need to configure the DLMS protocol according to their requirements. So what they need to configure? So some of the major points I've highlighted, there are 4 points here. The first one is define characteristics of individual objects. DLMS offers a lot of standard objects, more than tens of thousands of standard objects, abstract as well as electricity, gas, water, and heat objects are available in the standard. So the utility need to pick the right objects which they need in their system for their billing and operational needs. And in addition to picking the right objects, they also need to define the characteristics of the objects, because that will not be strictly defined in the DLMS. That need to be defined by the user, which is the utility. So example of characteristic means what shall be the data type of the object. So whether you need floating point integers, or you need the integer in 16-bit integers or 32-bit integers or floating point, and what shall be the access rights for certain objects, whether it shall be read only or whether it shall be read write, etc. So these kind of specific characteristics of each object need to be defined. Then pick the right data models. So here picking the right data model means that for some use cases, DLMS offers more than one option. There will be multiple options to realize the same use case. For example, the tarification or time of use metering, it can be implemented using a scheduled interface class of DLMS. And similarly, it can be also implemented using activity calendar interface class of DLMS. So the utility need to specify out of the various options offered by DLMS, which specific option shall be followed by the suppliers or implemented in the meters. Otherwise, if it is not defined by utility, it might end up that different suppliers follows different options, thereby leading to interoperability issues, leading to more cost and more time for integrating those two different meter makes. Then the next point is address gaps. So address gaps means that in almost all the utilities where DLMS has been deployed, we have seen that there will be around 10 to 20% of their requirements which is not fully met, which is not fully modeled available in DLMS. For example, in India, we have our electricity regulatory requirement that for the substation meters, the reactive energy when the voltage is low, that means when the voltage is less than 98%, and similarly the reactive energy when the voltage is high, that means greater than 103%, need to be separately measured. So that is a India specific regulatory requirement. So there is no standard object available in DLMS to model these reactive energy for high voltage and low voltage. So this is one example. Similarly, all the utilities and all the countries might have a few requirements which probably is very regional specific or utility specific and may not be available in the standard DLMS. So such gaps need to be addressed, that need to be filled. There is standard provision in DLMS itself. DLMS allows for utility specific or country specific extensions. So there are ranges of OBS codes reserved for utilities and for countries that can be utilized to define such gaps or utility or country specific additions. And the last point is specify the non-functional requirements. Non-functional requirements are those requirements which are not directly related or used in for their utility business. It may not be the electricity values, or it may not be there something that they directly use for billing purpose. For example, the security, the performance, the scalability. So such things of DLMS which are not directly related to metering or metering business can be called as the non-functional requirements, and that also need to be defined by utilities in their companion specification. Now, so this slide basically is trying to tell you the benefits or the relative benefit which a companion standard can bring. You can see there are two systems, system A and system B, trying to interoperate. So there is a smart meter from system A which is being communicated by a head-end system provided by system B. So you can see that pyramid. So the integration time and cost is highest in case of a proprietary protocol. That is very clear. And it comes down when the protocol is changed to a standard protocol like say DLMS or ANSI C12. But still, as I given some examples, just using a standard protocol, even if it is DLMS, may not be sufficient. That might even have some interoperability issues. So making a companion specification, a tailor-made companion specification of DLMS, which is suitable for a particular utility or a project, so that using such a companion specification will give the maximum benefits of the standard. Now, coming to some of the popularly used companion specifications. So generally the companion specifications are defined by country standards committee or consortiums or utilities. So the country standards committee examples in this slide are, there is the Bureau of Indian Standards, which makes all the standards, all the national standards for India. So they have the IS 15959, which is the Indian standard for metering, which adopts DLMS. Similarly, there is the NRS, which is the South African National Standards Committee. Then the consortium, there can be consortium of utilities or manufacturers. An example is IDIS. IDIS is a consortium of meter manufacturers based in Europe, or it can be of utilities. So most of the examples or logos in this slide are of utilities. Like the Tenaga National Berhad is a Malaysian national utility. Iberdrola is a Spanish utility. Then there is the CIG is consortium of Italian gas. TEPCO is Tokyo Electric Power Company. So, and then there is Saudi Electric Company, ERD of France, etc. So these are some of the companion specifications, national, consortium, as well as utility-wise companion specifications using DLMS. Now, the process of developing a companion specification So we have been a part of some of the companion specification development, which includes a national companion specification, which is the Indian companion specification, and also some cases of utility companion specification, that is the TNB Malaysia. So the process of making a companion specification is that the first is the requirement phase. So all the stakeholders are part of the committee which drives the process of preparing companion specification. So it includes the suppliers, mainly meter manufacturers, and the system providers, and the users, which are utilities and research organizations. So such a committee collects all the requirements from all the perspectives. It is discussed and debated, and the finalized requirement is then used for mapping. So generally a DLMS expert will be part of that mapping exercise. So the requirements are mapped to the corresponding models and objects or services of DLMS. So in that way, the DLMS companion specification draft is made, which is then circulated in various levels. Even it is goes for wide circulations, and all the feedback from various levels are taken. That is again discussed and debated to form the final companion specification, which is then released to public. So this is a general process that is followed to develop a companion specification. Now, coming to the DLMS use cases. So in general, most of the DLMS companion specification will cover these topics. So they might use slightly different terminologies, or the structuring of the document might be slightly different, but more or less the points that you're seeing in this slide. So these are the sections or the groups that will be covered in the companion specification. So under the functional heading, you can see the energy, demand, and other instantaneous data. Then the time and time synchronization related requirements, the load profile, then TOU, time of use or tarification, and the billing profile. Then events and tampers, that means the list of events that need to be supported, logged, and reported to the head-end system. Then power quality related events. What are the different power quality events, such as the voltage sag, voltage swell, high voltage, low voltage, etc. Then the load limit and demand response. And coming to the non-functional section, the meter identification, the parameters for identifying the meter, such as the serial number, the year of manufacturing, the country of manufacturing, the firmware version, etc. The association and security, then firmware update of the meter, then the communication setup or the different communications to be supported. Now we will have a quick comparison of some of the popular companion specifications. So we'll not name the exact companion specifications. So one of the use case, which is the time of use or tarification. So under time of use, we have noticed that most of the companion specifications will have the time of use inside the meter. So mostly using activity calendar. So the time zones or the time of use skit is programmed inside the meter, and the meter will accordingly capture the consumption or the billing data based on that time and write into appropriate memory within the meter. So that is the TOU in meter, inside meter. And in contradiction to this, in a few cases, in a few utilities, we have seen their companion specification which does not have the TOU inside meter. Instead, it is handled in the head-end system. So one popular utility which follows this practice is TEPCO, which is Tokyo Electric Power Company. So in their system, the head-end system or the MDMS system would be reading the load profile, and from the load profile, the system would be calculating the consumption or the billing related data depending on the tariff zones. So it is not the job of the meter in that case. Then single calendar versus multiple calendar. So again, most companion specifications that we have seen follows a single calendar for a tarification purpose. But in Iberdrola, the Spanish companion specification, we have seen they follow multiple calendars. So as per their specification, a meter shall support up to 3 contracts, and each contract can have 1 calendar. And the next point is the standard versus custom calendar. So in CIG, that is Consortium of Italian Gas, we have seen a custom specification or a custom definition of the calendar interface class rather than the standard DLMS activity calendar class. And the last point is the calendar activation. So related to calendar activation, there are various use cases, like what if somebody activates or somebody programs a past date for calendar activation, and when the meter is automatically activating a new calendar, should it do the billing of the values so far in the previous billing profile, etc. So these kind of things might be defined in some companion specification, but it may not be defined in some others. Like in the Indian companion specification does not tell the exact behavior to be followed inside meter related to calendar activation, but in some European standards like the Iberdrola, we have seen that they have strictly defined what the meter is supposed to do with the past data or the past date. Then coming to the load profile, the array types, the load profile buffer, there can be different types of array, like a normal array or a compact array. So that definition varies from companion specification to companion specification. Then the behavior of the buffer during power fail or a time change. Then the selective reset. Selective reset is a proprietary method that we have seen only in the CIG, Consortium of Italian Gas specification, where they can clear or reset some entries of the buffer from the head-end system. Then the custom selective access is something that we have seen in a vendor's companion specification, where the client can read selectively based on the serial numbers, not using the date and time. Then the last 2 point is the capture period and capture object. So the capture period can be programmable in most of the companion specifications, but what the meter shall do with the old data, that is the data before capture period change, whether it shall clear all the previous data or should it retain the old data. So that may not be defined in some companion specifications. Like in Indian standard, it is not defined, and both cases, that means deleting the old data or even retaining the old data, both are acceptable in Indian standard, whereas in some other standards, they will strictly say that you have to mandatorily retain the old data even if there is a capture period change. Now coming to the time and time synchronization. So there is a clock object versus the Unix clock object. The Unix clock object was found to be used in the CIG, Consortium of Italian Gas, whereas most of the others were following the standard clock. Then there is the time synchronization algorithm. So that also we have seen in the CIG, where they does not allow the sudden change, a big change of the meter time from the head-end system. If any time change request comes, the time shall be changed incrementally with say 10 or 15 seconds per minute until the new time is reached. But most of the other companion specification does not have such a restriction. They allow us to change to any new time, to jump to any new time without any restrictions. Then coming to the security, there are different types of securities and different types of keys. So that varies from companion specification to companion specification. Then coming to the push, that is the data push, the different types of push, the triggers for the push. it can be an event triggered, or it can be a schedule which is triggering. So all that varies from companion specification. So once a companion specification is defined, then generally what the utilities follows is that they will have a test procedure, a test process. So for the test process, the key is the test tool, or mostly it is called as functional evaluation tool, FET tool. So the tool is developed based on a test specification, which is a document which is prepared taking inputs from the DLMS specification as well as the companion specification. And then there is the meter test information, which contains the meter specific details such as the passwords or the addresses, etc. of the meter to be tested. So these two inputs are provided to the test tool, and the test tool runs the executable test cases. It runs the executable test cases, and the communication is logged into the log and traffic, and then the result or the behavior of the meter for the executable test cases is passed to a conformance assessment module, which detects the verdict, pass or fail verdict for each of the tests. Now coming to the test setup, what we have seen generally is that meters, almost all the meters will have an optical port, which is a serial based communication, and that will be connected with a computer which runs the FET, which is the test tool. And via this serial connection, the FET tool and the meter is communicating, and the FET tool performs the necessary tests. And the second, and the bottom part of the slide, what you are seeing is the case when the meter is being tested via the IP interface, IPv4 or IPv6 interface. So in such cases, an intermediate device like a data concentrator is used in between. Now we will see some of the tools that Kalkitech offers. So first one is a functional evaluation tool, which is used by utilities in India and Malaysia for testing their meters to verify if it conforms to a companion specification. So what you are seeing now is the window, the main window of our FET functional evaluation tool. So you can see on the left hand side, there is the list of test cases based on category. So out of these, the applicable test cases can be selected and that can be executed. Then you can also see the FTI tab. So FTI is the functional test information, which has the meter specific inputs like the passwords, the keys, system title, etc. So these are meter specific details to be provided to the FET tool for the tool to make a connection with the meter and execute the test cases. And on the bottom pane of this window, you are seeing is the communication settings, the serial or IPv4 or IPv6 settings of the meter can be provided using this window. Now, this slide shows a snapshot of a test report, a PDF file that is automatically generated by the FET tool. So it has the test group and different test cases for each of the test group. So this includes both positive as well as negative test cases and the result or the verdict. Now coming to another tool from Kalkitech is a DLMS simulator. So the DLMS simulator supports simulating DLMS meters, both companion standard wise or manufacturer specific configuration of meters can be simulated. And this is actually a large scale simulator which supports up to simulating 1 million meters. And it also has automatic data simulation. You can configure for automatic simulation so that you will get some data changes just like the data which is returned by the normal meters instead of always returning with constant values. So this is an ideal tool for testing hidden system, the scalability, performance, as well as for demonstrating hidden system to utilities. So this screen, what we are seeing now is the configuration window of the large scale simulator. So there can be standard templates, a library of different meter templates. So it can be of meter specific. For example, you can see Itron SL6000 or Landis& Gear ZMD, or it can be companion specification wise, like you can see the CIG, IS 15959, etc. So these kind of templates can be configured using this tool, and that template can be collected together as a library. So whenever a simulation is required, multiple instances of one model or one template can be configured. As you can see, the add meter template window, so it is configuring 1000 instances or 1000 meters of the Indian standard IS 15959. So similarly, you can configure templates as well as you can configure the instances. You can configure up to 1 million meter instances. And you can even configure the events, the event logs, event push, etc. It supports all the smart functions like the connect, disconnect, switch, demand response, interface classes, security suite 0 as well as suite 1 with both symmetric and asymmetric security, data push. All such advanced DLMS features are also supported in this. And the last tool that we are going to show you is the Meter Explorer, which is a very quite popular tool, which is used for manual testing. It is used by meter manufacturers for their during their development time and testing time, as well as used by many laboratories for meter testing. So this window, this is a snapshot of Meter Explorer tool. So you can see on the top left hand side is the object list, which is downloaded from a meter. You can use this tool to download the object list of a meter, and the object list can be seen on the screen like what is shown in this image, as well as it can be saved into a CSV file that is also shown in the bottom right hand side of this slide. So it can be saved to a CSV file so that it can be later opened in Excel, Microsoft Excel. So the object list includes the OBAS code, interface class, the attributes, the data types, the access rights, etc. And on the bottom side, you can see there is the traffic pane, which displays all the incoming and outgoing packets with meaningful comments that can also be logged into a text file, which can be used as an evidence of the testing. So this second window of Meter Explorer shows a load profile. So with the timestamp, one of the capture object, the power factor, then the current and voltage. You can read using selective access, or you can read the complete buffer. And this load profile buffer also can be saved as a CSV file and opened using Microsoft Excel or similar tools that opens up CSV files. So to conclude this webinar, so based on our experience in the past around 15 years, we have worked with OEMs, meter manufacturers, software companies developing hidden systems, utilities, test laboratories. So we offer consulting services where we can provide our expertise in consulting as well as software development. Plus, we can provide the tools, the meter testing tools and simulator tools, as well as we provide trainings and workshops also on DLMS and companion specifications. So with that, I'll wind up the presentation, and now we will open up for questions that you may have.
So Balu, there is a question from one of the attendees.
Okay.
Is there a possibility that a particular clauses in the companion standard that we develop contradicts to the clause in the colored book, DLMS colored book? What will be the resolution in such a case?
Okay. Yes. So if there is a companion specification and which has maybe a clause which is contradicting the standard DLMS, then the companion specification will have the precedence. So we have seen, so one such companion specification that we can think of is TEPCO, Tokyo Electric Power Company specification. So they had a lot of deviations from the standard DLMS, and few of their requirements in their companion specification was outside of DLMS, related to the say the connection related, like if there is a data link connection disconnection request from a DLMS client, as per their specification, the meter shall not disconnect. Meter shall still continue with that connection, because their companion specification was actually between the communication module which is inside the DLMS meter and the actual DLMS meter. So it is not really between the meter and a head-end system. So it was like the meter main board, which is the DLMS server, and the DLMS client is a small daughter board add-on card, which is also sitting inside the meter enclosure. So probably they did not wanted to have any disconnection. They wanted to have a, a full-time connection between the DLMS client and the DLMS server without any disconnection. So they had said that even if the DLMS client sends a disconnect request, the meter shall not disconnect. So that's an example. So in such cases where a companion specification is like contradicting the DLMS, the precedence will be given to the companion specification.
Balu, there's another question from another attendee. For a meter to be DLMS compatible, that is certified by the DLMS Association probably, should all protocol functions be available in that particular meter?
No. If your question is about the DLMS User Association certificate, then the answer is no. You don't have to implement all the DLMS features, and in a way that is practically impossible, because DLMS is such a huge protocol and it does not make sense to implement everything of DLMS in the meter. And the DLMS certification itself says that there are only a few mandatory requirements. For example, coming to the data COSEM objects testing, there are only two objects that are defined as standard objects. One is the current association object, and second one is the logical device name object. So only these two objects are mandatory. So if in the worst case, if a meter goes with only these two objects, he can still get a certificate provided he has implemented these two objects correctly. DLMS does not verify whether you have implemented any other interface classes or objects. So the way the DLMS test during their certification test is whatever you declare in the CTI, that is the conformance test information, as the capabilities of your meter. So only those features will be tested. So there are only very minimum mandatory requirements that you need to support, and remaining requirements, it is up to the manufacturer what to decide what to implement and what not to implement. If you implement that and if you declare that in the CTI file, then it will be tested by DLMS. So no, you don't have to implement everything of DLMS to get a certificate or conformance.
Sounds good. Balu, it's not a question. He's saying, thanks for the information. Please show again the first slide about the standards, maybe the 3-layered approach.
Okay.
So he just wants us to show that.
Okay.
Maybe you can open that slide, part of the slide, and then we'll move on to the next question.
Okay.
Another question is, can your DLMS simulator support various companion specifications?
Yes, we can support. So currently we support a couple of companion specifications, and even if there is a new companion specifications, then in a very minimal time it is possible for us to quickly configure that and uh, provide the support. Yes, it is possible.
So there's another question from another attendee. Is there a way to save this presentation? So basically, we will send out a recording of this webinar to all participants. So that hopefully answers your question. There's another question from a gentleman. How do we purchase your test tools and how can we get our DLMS product certified?
Yeah, regarding purchasing of the test tools, I think you can have a discussion with Gautam. You can take it up, right?
Yes, yes. So you can send out an email to marketing@kalkitech.com and we will come back to you. About
Yeah.
the second question, how
Yeah,
can
and
we get
regarding
our DLMS product certified?
yes, so that also we do provide that service. We have a validation assistance package, and we have provided that to many of our customers from various countries. So we can take that discussion offline. Yeah.
Yeah, sure. So again, you can send out an email to marketing@kalkitech.com and we'll get back to you. Balu, one more question. How to reach an agreement for a companion specification in a country with so many players involved, utilities, providers, regulators? How we can start to looking for this real standard?
So um, so India is a very good example for this question that you have asked, because it's such a big country geographically, and there are so many states, so contrasting states, and so many players. There are so many meter manufacturers and utilities from government and from private sectors. So it took many years, maybe 5 years or more, for us to reach to a finalize and have our first version. So I think 5 or 6 years it took, and in 2011 we came up with our first standard. So as I had mentioned in that companion specification development process slide, so we need to make a committee, and that need to be from a very authoritative side. For example, in India, it was being driven by the Ministry of Power, and the committee will have senior people representing all the major stakeholders. So majorly from the leading meter manufacturers of the country, and then the leading utilities and some leading research organizations. So this committee was formed under the Bureau of Indian Standards, under a technical committee of that. So that was the process, and there will be so many contrasting opinions coming in, and typically saying the utilities or the users would want as much features as possible to be included in the specification, whereas the meter manufacturers or suppliers would want to reduce. So that's what we have seen in Indian standard making process. So there will be a lot of disagreements initially, many rounds of meetings, and maybe many years, and finally there is a common point. So there is a compromise, and we makes a draft, and so that's a process we have seen.
Balu, one of the last questions. How will companion specification take care of DLMS standard revisions?
Yes, so that's also an important question. Like the developing a companion specification is it does not end with the release of the first version of the companion specification. So once a companion specification is made, a final version is made, still there is work to be done. So generally there is a maintenance group which meets periodically, like say once in 3 months or 6 months, or at least once in a year. And it will be reviewing all, they will be getting a lot of inputs in the course of time from the market and from the standards bodies, like the international standard, like the DLMS standard itself might change. So something might change, some new things will come and add. Similarly, from the market, there are new change requirements coming in. So all these inputs are reviewed by this maintenance committee or a standard governance committee. And so they will decide like which inputs to be considered as valid inputs. And they will also see the impact that this will make to the previous version and the impact on the ongoing projects based on this previous version of specification. So basically there is a standard governance process which takes care of such change requests based on the industry, based on the standard bodies and from the market and the users. And so the companion standard generally will have revisions. For example, in our Indian standard, the smart meter specification, which was released in 2016, has got 3 amendments in the past 2 years. After 2016, there was 2 amendments with some corrections on the base standard, some additions to the base standard, etc. So the companion standard also keeps on changing.
Great. Balu, if we've got time for the last question, we can take the last question. Else, I think we can wrap up. Last
Yeah,
question
we can.
is DLMS User Association certificate sufficient for companion specification compliance?
No, the DLMS UA certificate is not sufficient for a companion specification compliance because, as I said, the DLMS User Association does not really checks on the functionality. For example, even if the somebody is making a residential single phase electricity meter with DLMS protocol, and if they go to a DLMS User Association certification, so without any relevant data like voltage or current or energy or power or load profiles, any of the typical data expected in a single phase meter, if none of this is present in a meter, but they can still get a DLMS certificate. So the reason is that I earlier explained in to an answer to one of the question that DLMS has only 2 mandatory objects, so which is nothing to do with metering. It is the current association object and the logical device name object. So if only if these 2 objects are present, still that manufacturer can get a DLMS certificate. So that does not, DLMS certificate in that sense does not ensure the utility or the end user who is going to use that meter in their project, that it will meet their system requirements. It will generate the necessary data in the standard format, ensuring interoperability. So those things cannot be guaranteed with the DLMS UA testing. So generally, most of the utilities following a companion specification will have a dedicated companion test procedure using tools like the FET, the functional evaluation tool, which might be in addition to the DLMS UA certificate. So the utilities might ask for a DLMS UA certificate as a prerequisite, but still they might evaluate the meters in their laboratories using their tools like the FET tool to make sure that it has all the necessary objects and it is interoperable.
Sounds good, Balu. Thanks a lot. We are out of questions and out of time also. Uh, Firstly, I'd like to thank Balu for the great presentation. Secondly, thank you to all the attendees for taking time out for attending this webinar. We will be sending a recording of this webinar shortly to all the participants. Hope you enjoyed the webinar and have a great day. Thank you all.
Thank you.
Thank you.